solving the code problem 3246. So matrix diagrams. This is today's POTD. So you are given an n-to-n square matrix of integer grid. Return the matrix such that the diagonals in the bottom left triangle, including the middle diagonal, are sorted in non-increasing order. The diagonals in the top right triangle are sorted in non-decreasing order. So we had got a grid that, as you can see. So these black lines represents our bottom left triangle, and the blue line represents our blue arrows for our top right triangle. Okay, so in this bottom left triangle, we need to do the decreasing order. We need to perform the decreasing order like 861. Here we need to perform increasing order 27. So let's see more in more detail. So we got an n into n integer grid, and non-increasing order means like this decreasing order we need to follow, and non-decreasing order means increasing order we need to follow. As we in black lines we got black arrows. It is non-increasing or decreasing order we can see. So it's changed, and they remain the same because they are already in decreasing order, and it does not have any number. So blue arrows, it is increasing order we need to do. Like the 3 remain unchanged, as you can see here. 3 is 1 only, so it should remain unchanged. And 7 2 will be in increasing order to 7. So let's see the constraints. These constant called as structure constraints. So the range, as you can see, is 1 to 10. The smallest grid can be formed is 1 into 1, and largest grid can be formed is 10 into 10. And grid is equal to this size. This is called as size constraint. And so as you can see, the rows is equal to columns, and columns is equal to n. So rows equals columns, and columns equals n. So if n is equal to 2, then row is 2 and column also 2. That's why it's square matrix. So this is called as value constant. Each cell in the grid can hold integer from range minus 100,000 to plus 100,000. So in every cell, we can have both negative numbers and positive numbers. Example, n is equal to 3. So the grid is 3 into 3. For example, I will show you. In this, negative numbers also can be like this. For that, it has a minus 1,000 also. So negative numbers also can be in that grid. So let's see what we can do. As you can see, it's very simple problem. Just we need to get the diagonals parts from out. We will keep diagonals in an array list, and after that we will do perform sort operation on that based on increasing or decreasing based on what it is, bottom left triangle or top right triangle. Based on that we will do that, and after that we'll again change that grid numbers to back to original. After changing the order, we will keep that in again into the grid. Let's try to code this. Okay, so first we will create our n variable. That is very important here. Then we are gonna do, I will create a function for sorting our diagonals. Private void sort diagonal. In that we'll keep int r for rows, int c for columns, int of matrix grid, and we'll also keep a boolean. Based on that, we'll decide whether we need to do this bottom left triangle or top right triangle operation. So for the diagonals. So here first we will create our list. First we need to create our list of integer. We'll keep name as vex, something like that. Here you can keep anything. So new array list. Next we will declare our I with our row and our j with column, that coming from here. And next we are gonna do an while loop. I is less than n and j is less than n. For putting inside our vec the diagonal values, grid of I comma j. We'll do I plus plus and j plus. Then we'll also have to define our sort operation also here. So if, as we declared here, ASC, async, we will keep here only async directly. So if it's true, it will be directly gets executed, and our top right triangle will start getting sorting the diagonal for increasing order. Okay, so vec, sorry, we need to, it's array list, right? So collections dot sort, like else we'll do vec dot sort collection for getting our decreasing order, right? Here for bottom left triangle, we are putting this collection dot reverse order. Now we are going to again make int I as our back to what we have given in this, so that it will again do the same operation. Now we have to keep that vec values of the sorted order back into the grid at the right position. So how we remove them, like that only we will gonna keep them. So for int of val vec inside our grid I comma j, one by one we will keep values and keep on incrementing I and j. Same like a while loop we are doing here again to keep the values inside the grid. Here we done for getting values from grid to the vec, and here we done for changing the values from the grid to the sorted values of the vec. So next, it is done. Function is done. Now we are gonna do our sort matrix code. So here we will declare our n as n already declared here, as you said. It is very important. I have created already. So n is equal to, we'll do grid dot length. Then we'll run a for loop for our rows is equal to 0. We are going to do this for our bottom left triangle. So it starts from here, right? 0, 0, comma 0. It starts from here like that. We are going to keep row is equal to 0, and row is less than n, row plus plus. We need to run our function which we created. What is it? Copy exactly. So in that, we need to give our row and column we will keep as 0. Then we will give our grid. And in this, we need to perform decreasing or decreasing order operation. So we will keep as false. So it will go here and perform the reverse operation, reverse sorting operation. Next, we'll run another for loop for our top right triangle. It will start from 1. So we'll keep column as 1, column less than n, column plus plus. Sort diagonal again, we'll call our function. Now we are going to keep row as 0. As you can see, it's starting from 0 row, and column we will keep as our col, and grid, and this will keep as true because we want to ascending order. So we will call this function, right? So we are giving true. If condition, this condition we need to call. So we are giving true. Now we are going to return our grid here. Let's see. So there is one spelling mistake like this. Where everything is correct. Collection reverse. Okay, let's check. Collection. So we haven't, we forgot S here. Okay, now everything's correct. Let's see. Yes, all test cases pass. Let's see by submitting. Oh, it's kind of similar which we had done previously. So I'm doing this one also. So in this we need to do straight away diagonals in our ascending order. So it is more simple than the previous one. So first we'll create our function. So let's create a private void diagonal elements or diagonal sort. In this we'll give int of row will always give, so int of c also give column, and we'll also give our mat, which is our grid. And next we'll also give like int of n for our rows and columns. And let's explain more further in this how why we are taking this. So here int of, so here we'll create first int of n mat dot length for rows, int of n mat 0 dot length for columns, for int of row is equal to 0, row less than n, row plus plus. Diagonal sort, give here our, oh yeah, forgot to declare our things here. So here we will give our row column as 0 like before, mat we will give, and we'll give our row and column length also. Now we'll also run for column also. It's starting from 0, so it will do for this part only. For this also we need to take care, right? So for that we are doing for this column also. And stop Right also we are doing. So one we will keep column less than n, column plus plus. Here also we'll do diagonal sort function. Yeah, and here row we have to give 0, column will give mat and length of rows and column. And finally we'll return out diagonal sort. Sorry, I mean mat. Okay, now let's do these operations here. What function will we declare here? So here, int, first we need to create our list array like that same list integer. We'll keep here also back new array list. And now we are going to declare our int of I is equal to as r and j is column. We are going to run a while loop and I is less than n and j is less than n, and do z dot add max I comma j. As we need to do only one side here, only one ascending order operation, we are doing collections dot sort. Like next we will again declare our I as r. We probably forgot to increment here. Yes, we need to do increment. How it will go further? Yes, now we will again turn them as our initial values which we given here, which were given here, and to here. Okay, so let's do j is column. Let's keep back that values which we sorted in back to the mat. Okay, for that int of val mat, I don't know, sorry, back which we need to give in mat. So mat of I comma j, same operation we are doing here. Also, we will keep that value inside that I plus plus j plus plus. Let's see it will work or not. Let's run index auto count vec dot add mat of ij. So then something, let me see. Yes, so we forgot to keep here m, right? We are not just declaring one variable here. We are declaring two variables, like for rows length and column length. Now everything looks fine here. Here also and then perfect. Now let's see. Yes, accepted. Let's do submission and see. That's all, guys, for today. Thanks for watching.